All right, so the last video we introduced you to the three special types of right triangles that we have. So let's take a look at each one of them. Okay, first of all, let's start with the 45, 45, 90 triangle. And again, why it's called a 45, 45, 90 triangle is because, ladies and gentlemen, it has two 45-degree angles and a 90-degree angle, which add up to 180 degrees. Now, the nice thing about this is the two. Now, remember, let's do a little terminology here. This is the hypotenuse right here. Okay? That's the longest side opposite the right angle. Okay, there's your right angle, it's opposite of it. All right? Now, the two legs here, because the angles are the same, or because this is the reason why the angles are the same, the two legs on a 45, 45, 90 triangle are congruent. They are the same length. Now, I'm going to show you the relationship here between the hypotenuse and the two legs. Now, if you were missing any one of those three sides, you could always use the Pythagorean theorem. That's always your fallback. But we have some shortcuts which will eliminate your time, ladies and gentlemen, if you need to. By the way, this is called an isosceles right triangle, again, because it's got the two congruent sides. Now, I'm going to do a little abbreviation here, okay? I'm going to let HYP be the hypotenuse, and I'm just going to use the leg for leg. So the relationship between the hypotenuse and the two legs, ladies and gentlemen, is that the hypotenuse in any 45, 45, 90 triangle, the length of the hypotenuse is always equal to the length of one of the legs times the square root of 2. Okay? How do you come up with that formula? Ladies and gentlemen, it's using the Pythagorean theorem. Okay? And you just solve it for the hypotenuse. So, in other words, ladies and gentlemen, if you remember this relationship in a 45, 45, 90 triangle, you can find any side of a 45, 45, 90 triangle without having to use the Pythagorean theorem. Now, if you don't remember this, remember, you can always go back and use the Pythagorean theorem. That's our fallback. Okay? Now, let's take a look at the relationship in a 30, 60, 90 triangle. Okay? Ladies and gentlemen, as you can see, the hypotenuse again is always located opposite of the right angle. It's the longest side of the triangle. Okay? Now, the two legs here are not the same length. There's a shorter leg and there is a longer leg. Okay? The short leg is always opposite the smaller of the two angles. So this right here is the short leg. All right? Now, the long leg is always opposite the longer or the larger of the two non-right angles, the 60-degree angles. So this is the long leg. Okay? Now, there's a relationship here between the long leg and the short leg and the hypotenuse and the short leg. The short leg is the anchor here. It's the key. Now, I'm going to again do some abbreviations. I'm going to use HYP for hypotenuse. I'm going to use SL for short leg and LL for long leg, just to save us some writing. So let's take a look at the relationship between the short leg and the hypotenuse. Well, in a 30, 60, 90 triangle, the hypotenuse, the length of the hypotenuse, is equal to the length of the short leg times the square root of 3. Excuse me, I'm wrong there. Excuse me. Times 2. Okay? The short leg, if you double the short leg, you always get the hypotenuse. The hypotenuse is always twice the length of the short leg. Okay? Now, the long leg is equal to the short leg times the square root of 3. All right? Now, again, how do you get these relationships? Pythagorean theorem. But they allow you to be able to find missing sides on this 30, 60, 90 triangle without having to use the Pythagorean theorem. So if you forget these, you can always fall back on your Pythagorean theorem. Again, hypotenuse is equal to the length of the short leg times 2. And then the long leg is equal to the short leg times the square root of 3. So 2 down, 1 to go. The 3, 4, 5 triangle. Now, the 3, 4, 5 triangle is not named based on its angles, it's named based on its sides. Okay? Again, 3, 4, and 5 are the smallest whole numbers that we can form a Pythagorean triple with. Again, a Pythagorean triple just means you can take a leg, square it, the other leg, square it, and that equals the hypotenuse squared. Well, the smallest whole numbers we can use to get that, make that relationship work is 3, 4, 5. So the thing you need to remember here, there's no real special formulas or anything like that. But again, the length of 5, ladies and gentlemen, is opposite the right angle because it's the longest side. Okay? The shortest leg, the shortest side here is opposite the smallest angle, which is 37 degrees, approximately 30. It's not exactly 37, it's approximately 37. So that smaller of the two non-right angles is opposite the 3. And then lastly, 53 degrees is the other angle, or excuse me, 53 degrees, yes, is the other, approximately 53 degrees. That's longer than the 37 degrees. So that is opposite the longer of the two sides, the 4. So this angle is opposite 4. So 37 is opposite 3, 53 is opposite 4, and then 5 is your hypotenuse. Again, you can't use the Pythagorean theorem here because we have the lengths of all the sides. So you got to make sure, again, the 5 is opposite the hypotenuse. The approximately 37 is opposite the shortest leg, 3. And then the 53 is opposite the 4. Now, by the way, this works for any combination of 3, 4, 5. So it'll work for when the sides are 3, 4, 5. It'll also work for any combination of those 6, 8, and 10. Or if you want to say triple 3, 4, 5, 9, 12, 15. So any multiple of 3, 4, 5 will work here and have angles that are approximately 37, 53, and the right angle of 90. So we're done with this. Now we're done talking about in the next videos. We're going to look at some examples.